Productivity refers to the efficiency with which tasks or goals are completed. Productivity is measured by output versus input. In our engineering activities, we are asked to be more productive, meaning we need to finish the work faster. Recently, everyone is talking about using AI tools to be productive, but besides AI, there can be several simpler tools to improve productivity. For example, we can use web scraping, RPA, and Excel macros. Each of these tools is used in different scenarios, but a common thing among these tools is that they are applied for well-defined tasks. Well-defined tasks means we know what needs to be done, what steps need to be followed, where the information is available, and how the information needs to be processed or calculated. These three tools are particularly helpful when the tasks are repetitive. Firstly, WebScraper is a Python-based tool used for scraping information available in an organized way in websites. These websites could be either internal, suppliers, or third-party. The scraped information can then be presented in a template, which can be previewed on a HTML UI or downloaded as an Excel file. Moving on, RPA. RPA stands for Robot Process Automation. RPA is used for rules-based processes with structured and repetitive data. Put simply, RPA mimics human actions. It can click and open websites, emails, and databases, and can collect or write information. There are multiple applications of RPA, including Power Automate. Power Automate is a cloud-based service from Microsoft that allows users to create automated workflows between apps and services to synchronize files, get notifications, collect data, and more, without needing to write code. Lastly, an Excel macro is a set of instructions written in VBA that automates tasks in Microsoft Excel. Macros can do repetitive tasks such as formatting cells, copying data, generating reports, or performing calculations. Excel macro is particularly helpful to organize data into standard user forms and dashboards. I've been working on these three productivity tools, and I will go through a project I have done for each productivity tool now. I'll walk you through a full stack Python project where I built a web scraper using Python and a web scraper user interface using Flask and HTML. This is my project on web scrapers. I developed a web scraper with an HTML UI to collect data for EDS components from a supplier website. Normally, extracting this data is a manual and time-consuming process. You need to open the website, search for components, and copy the details manually. But with the web scraper, things change. We can automate this process, as it quickly collects information and even allows us to save it into a database or an Excel file. The goals of this project include to scrape at least 3 components from one supplier website, to set up HTML UI to display scraped information, and to record the time taken to scrape and display component information on HTML UI. Instead of diving straight into the code, let's start with a quick demo to see how it works. Here's the web interface I built. At the top of the page, you'll see 2 drop-down menus, one for selecting the supplier, and one for choosing the specific part or component you're interested in scraping. This is important because my scraper is designed to work dynamically, meaning it needs to know which supplier site to target and what part to search for. Once I select a supplier and a part, I click the scrape button over here. When I do this, the front end sends a post request to the Flask server in the background. Flask will then call the webscraper.py Python file, which uses Python libraries like requests and basic beautiful soup to fetch the supplier's web page for the selected part. It then parses the HTML, extracts the relevant data like part numbers, descriptions, weights, and scrapes it into a JSON file called scraped_data.json. While this is happening, notice the loading animation of a spinning wheel over here. This shows the user the scraper is working and prevents any accidental clicks on another button, which may disrupt the scraping process. Once the scraping is done, you will be able to see a clean table preview of the scraped data over here. This is created by Flask checking if the JSON file exists, and if it does, it loads the data within that JSON file and passes it to the HTML template using Jinja 2, which renders it here in this beautifully formatted table. And you are able to navigate this table by using the preview buttons at the bottom of the page. Now, let's say I want to save this data for later use. I click Extract to Excel, and a pop-up modal appears for asking for a file name. This modal is controlled by a simple JavaScript. When I enter a file name and hit save, let's say example, Flask calls extract.py, and that script reads the JSON data and writes it to an Excel file using the pandas Python library. Here's the Excel file created with all the scraped information. So, with just a few clicks, the tool has automated what would otherwise be a time-consuming manual task. Now that you've seen how it works, let's break down how each piece of the project comes together.
Let's dive into the heart of the project, webscraper.py. This script does all the heavy lifting. It fetches product categories and links from the supplier side. Then, it scrapes detailed data for each product and it saves everything into a JSON file. I started by importing Python libraries such as requests and Beautiful Soup. Then, I began to filter all the hyperlinks within the supplier's webpage and filtered it down to only the hyperlinks which contain data about the product details. And then we take the part number from the command line. This allows the scraper to dynamically target different categories like tape, connectors, tubes, or retainers. Based on the selected part, I map it to specific category URLs on the supplier side. This design keeps the scraper flexible for future categories too. Then I use multi-threading with Thread Pool Executor to fetch product details faster, as it lets us scrape multiple product pages in parallel, cutting down the total scraping time. Fun fact, this has allowed us to reduce the initial scraping time for a component with more than 4,000 products from over an hour to less than 5 minutes. Finally, after the scraping is over, the script will save the result into a JSON file called scraped_data.json. And this allows for faster scraping since it avoids the overhead of Excel formatting during scraping. This JSON file now acts as a raw database for the rest of the app. Next up is extract.py. This script reads from the scraped_data.json file and creates a beautifully formatted Excel file, which we had seen earlier. Here, we first loaded the data within the JSON file into a data frame. And then we exported this data over here into an Excel file. And finally, using the Python library openpyxl, we were able to format this Excel file. As seen before, the formatting of the Excel file included alternating column colors, column resizing, and text wrapping using openpy.xl. Now we will move on to our Flask app, which acts as the glue between these two scripts and the browser. Starting off, we imported Flask modules such as Flask render_template, request, redirect, flash, and JSONify. We also import modules such as JSON, math, subprocess, since we will need them for file handling, pagination, and calling external scripts. Next, we initialize our Flask app with this. The secret key lets us use Flask's flashes Flask's flash messaging system to show success or error messages after action like scraping or exporting. Here's the load underscore products function. This function checks if scraped underscore data.json exists, and if it does, it opens the file, loads the JSON data, and filters out completely empty rows where all values are none, empty strings, or NA. This ensures the user only sees valid product data in the preview. If the file doesn't exist yet, it simply returns an empty list. Now, let's look at the main route. This route does three key things. First, it loads the product data using load underscore products function, handles pagination logic so we don't dump all data on one page, and it renders index.html with the data and some pagination variables. Here you can see the pagination logic. It calculates how many pages of results we'll have and slices the lists for the current page. And then finally, we send the data to the template. Here, has underscore data helps us control whether to enable or disable the extract to Excel button on the front end. This is a simple API endpoint. It serves the clean JSON data directly. This could be handy if we ever want a React front-end mobile app or even a third-party system to fetch our data. This route gets called when you hit the scrape button. It pulls a selected part type from post request and runs webscraper.py using the subprocess run. If the scraper runs successfully, we flash a success message. However, if there's an error, we flash an error. Then we redirect the user back to the home page. Finally, here's the route that handles the export to Excel. This runs extract.py, which we had just seen, and it writes the data into an Excel file. And again, we flash a success or error message and redirect back to home. So that's a full walkthrough of the Flask routes powering this app. Now that we've seen how the backend web scraper does the heavy lifting by collecting and storing our data, let's move to the part the user actually interacts with, the web interface. Our Flask application serves a dynamic HTML page, which acts as the control center for the entire process. When the user first visits, Flask loads index.html, which gives them the option to pick a supplier, a part type, start the scraping process, or extract the data into Excel. The data scraped earlier is stored in a JSON file, and Flask reads this file and processes the contents to the HTML template with the assistance of Jinja 2. The HTML provides a clean UI with drop-downs for supplier and part type. Buttons should trigger scraping or extraction, and a preview area for the scraped data. The product's preview section uses a Jinja 2 loop to dynamically display each product. It shows details such as part descriptions, product group, material, color, and much more. Missing data? That's handled gracefully with a fallback value like NA, so the user isn't confused. To keep things user-friendly, we added CSS for styling, buttons with hover effects for feedback, pagination for easy navigation, and the product preview using a table or card layout for easy readability. I also added a modal pop-up over here, and this appears when the user clicks Extract to Excel, as we had seen before. This modal asks them to enter a file name while dimming the rest of the page to focus their attraction. JavaScript brings our UI to life. When the user starts scraping, the tool shows an animated circle right next to the scrape button. This keeps spinning until the scraping is finished in the background. And when the user hits Extract to Excel, a modal pop-up appears without refreshing the page.